So, to introduce today's speaker, our guest is Arman Khalatyan, who is a scientific staff at the Leibniz Institute for Astrophysics Potsdam, AIP. That's also where he did his PhD, and then he spent his postdoc time in Marseille in France. He then has been back in Potsdam since 2010, and in his career, he bridges astrophysics and advanced computing. And the research topics are spanning from galaxy formation, hydrodynamic simulation, and the analysis of Gaia mission data. He's also a member of the Star Horse team. At AIP, he's responsible for high-performance computing and the e-science infrastructure. And he's also very engaged in the German national research data infrastructure efforts, including especially Punch for NFDI. And Arman is a developer behind platforms at AIP, and I'm sure that he will tell us a bit more about it today. And now, Arman, it's your time to take over. Thank you very much and welcome.
Thank you very much, Anna, for inviting me for this colloquium. And thank you, everybody who joined us. So I would like to present you some few works what we have done at AIP about this LLMs, which is really hypey topic everywhere, but I would like to come from the side of the user. Like, I'm a user, I'm not an expert or research expert in LLMs. As Anya was mentioning, I'm a researcher at AIP, at eScience and supercomputing and IT, and doing a lot of astronomy. And I'm building the systems to assist for researchers to do extreme complex tasks. And for that, we need to have an infrastructure. And one of them, the main idea of whole scientific life is you have an idea, you start to collaborate, and you publish. This is daily bread for everyone in science. But in nowadays, in between, when you share your thoughts or start to collaborate, you might meet your future or current colleagues or not. In between of you and your colleagues, there are a lot of puzzle pieces of technology. And this whole journey is actually involving many steps. Like you need to read, you need to prototype, you need to reproduce results of others, share the data, make new plots, provide the data access to others, develop the software, find new findings, and then again publish. But in between, there's some few components of this whole workflow, which is always hidden from the researcher. They think this doesn't exist, like hardware, infrastructure. It should always work. If even email doesn't work, it's like today, if Zoom was not able to let us in, we were panicking, but we were thinking it must work in every second. And same thing in our case, in research, we have a hardware infrastructure, and this is a very important component of modern science. And we are at the AIP part of this NFDI for Punch, NFDI, this big, large consortium project. We wrote already a proposal for Punch 2 prolongation. And within this Punch consortium, we were in charge of this, at the AIP, we were in charge of these green parts, what we mentioned here, to make results reproducible in Punch consortium, and then later to expand that to bigger collaboration groups. And we were providing hardware and infrastructure, and also we were incorporating this, our hardware infrastructure at AIP with other institutions. But of course, this hardware infrastructure is simply hidden in all these steps for any researcher. What we brought to the life into the astrophysics or in the Punch, we picked REANA software stack, which is made by CERN team, leading by Tibor Simko. And this REANA is reproducible research data analysis platform. We just theorized out this REANA product from CERN infrastructure, made some changes, and we deployed at AIP for NFTI for Punch or for NFTI Consortium, that everyone who has a Helmholtz AI access, then you can use this REANA reproducible platform. And this is very important component to make your research reproducible. But this is new product, and this is extremely complex for the newcomers to use. Besides that, it was really made in that way that it should make the life of researchers easier, but it was not the case. And within AIP, with Harenga, he's a leader of our Eastern group, Elena Saki, she's also our colleague, postdoc in our team. And we had also student assistant Tom Strauss. We decided to build some kind of dashboard which might help researchers easy access to this infrastructure to run their jobs or new products. Not only REANA, other stuff as well. But we failed badly because these regular dashboards which are in the some kind of in the market, due to the complexity of our too many interdisciplinary projects within the Punch, it's very hard to get tool for all possible cases. What we thought, okay, well, we need to have many assistants, but we had only one Tom. Or we go to this new wipe coding way and say, okay, everyone is in wipe coding motto. It sounds like if the tool you need doesn't exist, just create it. And there are a lot of many tools which are really pay wallet, and you can spend a lot of money, but without results because of AI is not ready there, and you are using some infrastructure of others, and it might be a problem in some research case. So, but everyone says around in the news, use LLM to build some kind of prototype fast, don't read the code, ship it to users. And this is the part of the problem what we had. This doesn't work as we expected. So what we can do, maybe in the new era of petabyte data scales, we might think of new way to interact with the computers. Maybe like in a Minority Report movie, where you just move your hands and you have some holographic displays. Maybe this is new. Is it fun? Fictional, or it's achievable with new technologies? Then recently I was trying to achieve that effect, maybe using new technology like augmented reality, projected displays in my room, and trying to dig within the Gaia datasets. It's a large database of stars, over 1.7 billion stars in the database, to explore them. But you can see it's extremely hard and complex interact with the data with this way. So from this point of my slides, I would like to warn everyone who is in the meeting. Everything what I would say, it might be outdated maybe by tonight. And because this field is moving extremely fast. And what I would like to mention, that now I need your total attention, but maybe attention is all you need. And this is a very important phrase. I will explain you in a second. For those who is not familiar with these LLMs or this artificial intelligence, new hype technologies, I would like to bring into your vocabulary new keywords. AGI, artificial general intelligence comparable to human capabilities. AZI, artificial superintelligence, more capable than humans. And there's a theory, if you go to AGI, next step AZI will be achieved very quickly. Therefore, everyone is nowadays talking, we are getting almost closer to AGI, and AGI, maybe you will see in the news and newspapers everywhere, in blog posts, but we are still not there. The important thing that in neurolinguistic programming branch was develop new techniques like transformers, like large language models, some generative pre-trained transformers. This is another type of the LLMs, or this tool what we are using always in nowadays. Almost everyone is used to use this ChatGPT tool made by OpenAI company. And then since 2025, since January 17, there's a new terms are added into this vocabulary, reasoning. That means the LLMs, they are learned some based on some patterns. They are making self-reflecting, building some kind of reasoning capabilities, and also chain of thoughts, which is like reasoning process where you can also monitor how they are thinking, these LLMs. So why I was mentioning you attention all you need, this was the breakthrough in a LLM research by Google research team in 2017, where they found that if you build up specific type of the neural networks or specific type of network which can have some self-attention heads, then it will, for example, when you translate from German to English or from English to German, the direct translation, if you translate each word one by one, it doesn't make sense in another language. But if you take this method, it will provide you almost perfect translation. So how it works, you have some kind of neural network, and then you have some kind of architecture, then your letters or words are becoming some numbers. They are going over this infrastructure of this neural network. And this size of the sentence, how much text you can put at once into this whole infrastructure, is called context length. It's very important. Keep in mind. And then in the end, you get the results. So if you look, ChatGPT.com likes infrastructures, how do they work? You might think about, you have a lot of textual data, you train your neural network, then you freeze that, and this is release date of this neural network or this model. And this frozen model, now you start to use. And if the user giving some question, like how many stars in the car in this case, then it converts, it's some kind of grinding into the numbers, it's called vectors. And then those vectors are going into this neural network. And once it puts next answer, what he thinks most probable will come, next word or next token, then he attaches to this answer and then puts again and again. That's mean when you ask one question and you can see in the ChatGPT some text is coming very quickly, that this text is going in the loop within this infrastructure, within this language model. And then that means these sentences might become longer and longer. At some point, it might be truncated. So this is pretty cool. But if you use infrastructure of others, then your sentences or your questions, they might be used to make later training on your data. This means your data you give to the third party. The market of LLMs is very huge, and in nowadays it's much bigger because this tree is exploded in upper level because of some things are happened in the market after 2025. I will come to that later. So if you are thinking about what is the size of why it's called large language model, then you remember this textual data, what I mentioned. If you have less than 100 billion parameters, we can think about small models. If you have more than 100 billion parameters, some closed model systems, they might be over a trillion parameters, then this is large language model. So this is pretty cool that everyone was thinking this new era is coming. We discovered like nuclear energy or much worse cases, and everyone is going like mad And some people, they divorced it from the different companies. And then some other CEOs, they went to different Congress or different governments saying, oh, AZI or AGI is coming, be careful, and so on. And we need to have some regulations. But to host such a models, we need to have really huge resources. And that's the problem, that you cannot scale up infinity. So you cannot feed more and more data to those LLMs. And if you think about this, is LLMs, they require very explicit, very extremely fast matrix multiplication operations, and such devices, like you see on this picture, they can do that. And what's happened in the market, there's one big company, it's called NVIDIA. They started like selling shovels and making billions of billions money. In one night, they became 3.6 trillion worth company in 2024, November 7. Well, in the market, some people are producing hardware and some people are producing models. And most of the models are closed source. And the GPU seller says, buy more GPU, save more money. That's been they make trillions and trillions money on hardware. As a usual, Google was telling, it's the most capable model what we have. It's a Google model, Gemini. OpenAI was always telling, oh, AGI coming tomorrow or next day, but it was not the case, and it's still coming. But there's a one guy from former Facebook, like now it's Meta. He says, okay, we cannot go infinity in this LLM research if we wouldn't put these weights open. And that's happened. And they put it open source, but I strike here source because it's only open weight. That's mean you get only frozen trained model. You can maybe fine tune those models, train further, but what data was coming into that model, what algorithm, how do they use that to train? It's close. But that was bringing to other companies under the stress to make more and more better models. But one big breakthrough from this model business was that instead of pre-training and spending a lot of power on model training, you might think about, okay, we need to let models to think longer. That means you put your power consumption instead of training or post-training fine-tuning phase, you put into the interface. What does mean this interface? It's you can think about like if you let model think about the topic longer and more, the qualities become better. And this has happened actually. If you look in the end of the 2024, there's a huge jump in quality of models, for example, of OpenAI, that they shown that if you let this think longer, then you get maybe PhD level researcher for $200 per month. Questionable. But there were some other people are hyped in Twitter, and they've shown that the IQ of this model, which thinks longer, is much, much higher than IQ of previous. Of course, it might be wrong, but this is very nice, like napkin level science to say, okay, it's quite nice technology. And one of the interesting benchmarks was showing that if you have a PhD level science questions, then such models, they can overperform expert human in that field. That's mean if you give those special complex science questions, then experts, they might fail, but O1 type models not. Well, but there's not only one company baked from US exists. There's also some other companies are coming from Chinese. And there's something happened in 2025, January 27, when they released new model. And it was really pretty interesting model, which was breaking NVIDIA all prices down there in the NASDAQ and every where, and then what's happened, then these guys, they came out and they say DeepSeek model, it's open source, open weight, we give that for free, and the full model. And the same model is hosted now service you can use for free. Of course, everyone was claiming, okay, this data goes to China, everyone has your data if you use these services, but there's a very important thing. You can download those weights, like this 671 billion open weight model, you can download and host in-house. But there's a big problem. It requires more than 320 gigabyte video RAM, and this is not cheap. And also there's of course, this model is very capable. You would like to have in-house, in university or at institute, such models, but very expensive to host them. So let's go first to bring new keywords in our vocabulary. One of them is RAG. This is one of the methods where you can add new knowledge or missing knowledge into your LLM. It's called retrieval augmented generation. This means you have a frozen models and you have some database, and based on this database, first your model is querying information within this database and then answering you. But this means you can enhance responses. Another thing which really important technologies came out is called Agentic LLM. This means you allow large language models do some tasks autonomously. And then if you have Agentic LLM, which is able to do some tasks, you define a tool and give this tool to this task. That means this Agentic LLM becoming as an agent. This means this agent, what does mean? If you have for example, if you have an LLM, it's like frozen weights, and you ask him, what is the weather in Berlin today? This, to answer, it needs to call some specific tool or Google search or some service tool which goes to the weather station, asks this number, brings that, and reform the sentence and gives you right answer. This is pretty cool stuff. And this agentic stuff might be useful for our own science because you reduce hallucinations, you reduce knowledge cut, and might be the answers, they might be not negated so easily like now, because any frozen LLM, you can easily negate his answer by your prompt. Or maybe we can think about to host infrastructure by own based on those LLMs, reducing the LLM size. But as you know, from your experience, interacting with such LLM infrastructures, the most important thing is a prompt. That means what you are asking first. As you remember in the movie of I, Robot, Will Smith was trying to find out the answers, but when he asked to this device, which is limited LLM device, when he was asking right question, it was giving him right answer. And this is very important because our LLMs are trained in a limited knowledge base. Big problems in LLMs is hallucinations, scalability, bias, because if you train with one type of the data, it might be going into that direction and missing important information. Data privacy, if the closed models are somehow behind the infrastructure of third party, then you don't know what they are doing behind the scene. And for a researcher, it's a nightmare because we don't know this back infrastructure and we don't know how to reproduce the results what LLMs is giving you, because if one day they might update to GPT 5.0 to GPT 5.1 with new prompt, and your question what you were asking first time, the answer second time will give you wrong answer. So to build up infrastructure at AIP, we went in that direction that what to host LLM with all those tools, with agentic functionality and so on, you require many, many components. As mentioned in this slide. I don't want to go into detail, but you need a Kubernetes cluster, you need to have GitLab CI. Of course, we have a REANA and S3 storage and so on. So this is very complex infrastructure to maintain, but what I want to mention, if you have a GPUs like 96 video RAM together, you might host this DeepSeek Coder V2 with 236 billion parameters. So we did that. We bought a computer at AIP, and we hosted these LLMs on these dual GPUs. So can we self-host them and have a full control? Yes. Can we create a custom knowledge databases? Yes. And possible solutions may be agents, tools to improve the quality of answers? Yes. We built some rudimentary dashboard, but what we were missing, these all components or documentation, it was always too complex for interdisciplinary people or even for newcomers. So we thought we might be thinking to have some kind of button here, assistant who can help us with that. Well, from first view, what we wanted to have actually in reality, if someone asks for your paper, asking, could you make a pretty press release image from your paper that we can publish on our webpage and advertise your paper? What even for your private knowledge, you need to call all your collaborators because it's a very extremely complex paper. Machine learning is involved. It's 270 million Gaia. There are 3 stars. So it's very complex stuff. To make fancy, nice image, you need to call many, many colleagues. We were thinking, okay, what if instead of many, many colleagues and assistants, we would like to have some research assistant LLM who can do every step by its own, and we might have specific agents with specific functionality, like one is the coder, one is the executor, one is the tester, then it sends this information tester to the coder, one is the researcher, and then in the end the planner, when he passes all this data into the validator, it says, yeah, okay, thumbs up, go ahead and produce the results. And that was not so easy. So what we did, Tom did his bachelor work on that. Let's explore LLMs, which are open weight, and can we build up, based on open weight LLMs, some kind of agentic infrastructure which can produce reasonable results for our tasks. Simple task was, like we have an assistant, we ask him some questions. For example, in this case, an example of the assistant, you ask the questions and it always answers you Python tip of day, for example. And he says, I'm an assistant for Python tips. And every time when you ask him, give me tip of the day, or if you ask, what is the weather in Berlin, then it will say, no, I'm an assistant for Python tips and so on. So this was quite useful to learn how this old stuff is working. But then situations became worse because all those LLMs, they were less than 70 billion parameters. They were not able to answer REANA questions. That's mean this workflow type, how these YAMLs are created, how the REANA works, they were not able to answer the questions. So what we did, the test in Tom's bachelor work, it's public, you can go there and see the results. But the main idea was, if you answer questions on REANA to build up workflow, it was not able to answer correctly because mostly it was failing. But when you add the RAG, custom knowledge database, then it was very, very improved. The situation was very improved. That's what we used. And the situation became a little bit more complex in our LLMs. Here is a Flowwise AI chart, what you can see. So you have here some kind of knowledge base, then you have an LLM, then you have a supervisor, and the supervisor is also checking if this answer is appropriate for the question, yes or no, and he's letting on to get out in the end and give you an answer. But then we found some other drawbacks that users, they can even this some kind of tricks, this stuff, but then if you add there some guards, they can block this tricksing. And then what was a next step? What if we can add the real true math into there and coming with the custom tools? That was a main advantage of this agentic part, that you are able to call calculator, real calculator, not LLM, which can hallucinate 1 + 1 is 3, but real calculator, which calculates and returns numbers. Based on this technology, we were able to attach our custom tools. And what do we attach in this final flowchart? What you see is really extremely complex from the first look, but this is every element has his own needs. And in the end, what it was able to produce REANA YAML file, and it was able to show the chain of thoughts, how it works. And also, it was able to submit this created code into the REANA workflow, which was validator task, LLM validator task, which was checking if the workflow, what other LLM part was generating, is correct. And if you succeeded, real workflow was working, so LLM was providing us, is providing us the GitHub repository with the whole source code. This pretty cool experiment. Of course, here's a result, is hello REANA, but it was very cool. That's when if we have some interface where you go there and ask some question, in the end you get a code shown, and then you have a GitLab URL, which is providing you the repo. Pretty cool, but we didn't stop there. We thought, okay, we learned now how to make custom LLMs. Let's put there more stuff and add into our HPC documentation at AIP, the first deployed productive assistant at AIP, to provide the hints to users. Of course, documentation, the standard block elements are always here around. You can search, you can filter them by tags, but there's a new thing, some button in the right corner. If you click there, it says, I'm the HPC AI assistant. How can I help you today? But then if you ask here the question, what is the weather in Berlin? It would answer the same sentence here. I'm a HPC AI assistant. I cannot answer this question. That means this assistant is only answering the questions which are related only to these documents first, and next only everything which goes to the HPC AI or HPC related questions. And if you look, this works following. If you go to some document, and within this document, if you ask, without reading this document, you ask, okay, show me how to load models on the Newton cluster, it gives you almost same answer like in this document. It's pretty cool, pretty nice. So I would say I would come into the conclusion in this point for my talk. There are vast of ecosystem within so many tools that we don't know what to use in the first place. But selecting right tool for right production run, it's very hard. I believe the next step, these assistants, they will become as a new tool, everyday tool for researchers. And what I would like to say that we are developing special dashboard which can implement this LLM within the dashboard and search within the dashboard the components and provide the appropriate answers. And we are also we also submitted in the proposal. We are waiting for answer for ARM data, and we are part of the physics LLM and agentic workflows. If you have any questions on these topics, I'm open for the questions. And as I end, maybe I would like to let this run, how in real life it's working, and then I'm open for the questions. Thank you very much.